today we'll discuss exploring assumptions with SPSS. Okay. So
Hmm.
last class we discussed about outliers, like when we want to analyze any data, we need to see whether there is any outlier. We need to explore the data to know the
Hmm.
nature of the data. Okay. So in today's class, we'll discuss how we are going to handle the outliers, what we are going to do with if outliers are there, and secondly, how we are going to explore the assumptions. Okay.
Hmm.
So assumptions basically exploring assumption. Why we need to explore the assumption? Because that will help us decide what kind of statistics we are going to use for our data, right? So
Hmm.
okay, before that, I just want to rectify one mistake. Last class I told you that intelligence, creativity, they are continuous variable, but intelligence and creativity, they are always categorical variable. They are not continuous variable. Okay, so whenever we are using this variable in SPSS, we have to code them like the way we did in case of gender. Similar way, if we are using intelligence or creativity, we have to code them with the numbers. Okay.
Okay.
Okay. So these are the topic that I'm going to cover today. So I'm not discussing much because already I have told you.
Huh.
So now, how to correct problems in data. Okay. So if there is any outlier, so what we will do? Uh, One thing we can do always that we can, correct the data. Maybe it may happen that we have entered the data, it is a wrong data. So we have to check whether it is the right one, or we did any mistake when we were entering the data. So
Hmm.
we can do that. We can check the data, or we can but once we know that okay, it is a correct data, there we didn't do any mistake when we were entering data. So now we have to know how to handle it. Okay, so you can see I have written here there are three method of handling data. First, removing the data means deleting the data which create outlier. Okay, but obviously we cannot, like, maybe we don't want to delete the data entirely. Maybe one code is out there, but we don't want to delete it because data collect data, every data is important, right? So we can transform the data to correct the outlier, and we can change the score. These are the two way we can do if we don't want to delete the data. Okay.
Hmm.
Now, transforming data means there are certain method by which we can transform the data, and we can use SPSS to do that. So I will discuss that a bit later. Another process is changing the score. It means we can replace the score with another score, but that doesn't mean that I'm just randomly writing anything. Means many times. Many people do, or many times maybe we did that we just write a data and say that is our data. Okay, but that is wrong, that is not ethically right. So changing the score, there are also certain rules by which we can change the score. Means whatever I want, it's not like that okay, ये data ठीक नहीं है तो मैं कुछ भी लिख देती हूँ data अपने हिसाब से. It's not like that. We
Huh.
can change the score, but there are some rules for doing that. Okay, is it clear?
Yes.
So how we can do that? This is a process of changing. First, what we can do, if there is an outlier, we can what we can do that we can remove the outlier, and in that place we can write another score. The process is next highest score plus one. So suppose in your data the outlier is 223. Okay. Now
Hmm.
you want to change 223 and you want to write a data which is not an outlier, which will not create problem. So what you can do, maybe next highest score is 150. So you can write 151 instead of 223. This is the one way you can change your score. Am I clear?
Yes.
Okay. Then the second way, it is by converting Z score. Okay. Just let me open the SPSS, then I will explain you. Okay. So, okay. So hope you remember in last class I told you how to detect outlier by using Z score. Hope you remember.
Yeah, we have, we'll do the Z score and we'll see which one
Hmm.
is equal to or above 3.29.
Yes. So we can use use Z score to convert the outlier, change the score of outlier. Okay. So what is
Hmm.
the formula? This is the formula: x is equal to z into s plus mean. Okay. So
Hmm.
here z means the z means the 3.29, which is the minimum value. Okay. And into s means the standard deviation. Okay,
Hmm.
and plus mean means the mean of the distribution. So this formula you can use to change your score. Okay, this is
Hmm.
the second method. Okay, and the third method is mean plus mean plus 2 standard deviation. So what if your mean of the distribution is mean of the distribution plus 2 2 standard deviation, 2 into standard deviation. This is another way you can change your score. Okay. So this
Hmm.
is the three process of changing your score. Clear?
Hmm.
Okay. Now, it is always better if you can transform your score rather than changing. Okay. So now I will discuss how to transform our data and how we can use SPSS to do that. So is it clear till now?
Yes, yes, it
Okay.
is.
Okay. So data transformation. Uh, in data transformation, we have to transform all the data. Okay. Like in case of changing score, we are only changing that score. The score which is creating problem, the outlier. Okay. But data transformation means you have to change all the data, and then you are going to use that transform data in your analysis. Okay.
Hmm.
Now there are three methods of data transformation: log transformation, square root transformation, and reciprocal transformation. Okay. Generally, we use these three methods if the data is positively skewed. But if the data is negatively skewed, then also we can use this method. But there is a technique, there is a rule. Okay. So is
Hmm.
it clear?
Yes.
Okay. Now, the log transformation. Okay, log transformation. It is mathematical thing, so I will not explain you much here because we have SPSS, so you don't have to do anything manually. Okay.
Hmm.
So log transformation basically we use if the data is very skewed. Okay. So in log transformation we use a base of 10, which is called log 10.
Hmm.
Okay. And if the data includes zero or negative number, then we have to use a constant there. So let me show you how we can use log transformation through SPSS.
Huh.
So if the data is positively skewed, what we have to do, we have to go to transformation, then compute, and then arithmetic. Okay. So this is the data we have. Suppose this is a pre and post test measure of something. Okay. So
Hmm.
I can write here pre test test. This is the gender. I can give level here. Pre test of pre-test of anything, maybe the intervention on stress. Maybe we are giving between pre and post test. We are giving how to handle maybe how to handle stress.
And
Okay, so pre-test of stress. Test stress. Okay, then values. Okay. Now let's go to data view. Now we have to transform the score. Okay. So first we have to check whether there is any outlier. So how we are going to do that?
wait, we have to. We'll go to analyze
Yes.
or descriptive stats and wait, descriptives.
Okay.
Yeah, yeah, and then we'll put the pre-test and post-test to the variables column. Save standardized values as variables and OK. Okay, then we go to the data sheet. Yeah, so we'll put this in either ascending or descending order. Yeah. So over, and then we are supposed to check with 3-point tune in the extreme this thing. So we have this one 3.86.
Yes, this is the outlier. Okay,
Hmm.
but okay. Now, if I change the score, if I use the method changing, correcting outlier by changing the score, then what I will do, I will only change this score. Okay, but if
Oh,
I want to use transformation, then what I will do, I will change all the score. I will transform all the score, not only one score. Okay, so
okay.
data transformation is much better option than changing the score. Okay, now what how I'm going to do that? Okay, so uh, first I have to go to transform, then compute variable. Okay,
Hmm.
in compute variable we have to change the score. Okay, so we have to change, like first I will change the score of pretest. Okay, here I have to write log 10 underscore pretest. Okay, this one I will do later. First I have to write. Okay, so here in arithmetic you can see there is an option log 10.
Hmm.
Okay, just you have to click this arrow, then it will be here in the numeric expression. Okay, and here in the place of question mark, just send this code. Clear?
Hmm.
Fine. Okay,
Yes.
then click OK. So we have, oh, sorry, we have transform score for pretest. Okay, even if there is no there is no outlier, still we have to, because when we compare the two score, it's we cannot do that like in one score it is a raw score, in another one it is a transform score. We have to transform all of them. Okay,
Hmm.
so in the same way we'll do for the post test. Compute variable, then log 10 post test. Okay, select log 10 from here. Okay, and add post test, and then click OK. So we have here we have the transform data. Okay, now we can use this data. Is it clear?
Yes.
Clear. Okay, one more thing, just I want to show you this compute variable. Here many options, you can see plus, greater than, less than, minus, okay, greater than, equal to. So if you want, you can use this thing whenever we need it. Okay, clear. Okay. Now, this is the method we can use if there is all if all the scores are positive, and this is a positively skewed distribution. Okay. But if there is any negative score, or if there is any zero within the score, within the data, then we cannot transform data in this way. Then we have to do something else. We have to there is another formula. Okay.
Hmm.
So let me show you that. First, if there is any zero score, if there is any score which is zero within this data, okay. So now how we are going to change that? So just let me delete this thing, otherwise it will be difficult. Okay,
Hmm.
I'm clearing this column. Okay. Now suppose there is a score which is zero here. Okay. So what we have to do, in same way, like Go to transform, compute variable. Okay, test, test, test A maybe. Then log 10. Here what you have to do, simply you have to add 1 here. Okay, with the variable.
Hmm.
Just within the pretest there is a score 0, so I can and just add here we have the option plus 1. Clear?
Okay.
Okay, and then click OK. So if we add plus 1, then it will be 0, but it will be adjusted. But if we don't do that, if we follow the same process without, let me show you what will happen, then it will be clear. Okay.
Hmm.
Uh, Suppose we just use the same process. We don't add plus 1 here. We just simply,
Log
okay. So you can also drag here if you want,
10. Okay.
or you can use this here. Okay. So in pretest, okay, you can see no score is here.
Blank, huh?
Okay, so we can say okay, it is 0 and blank. What will be different? But yeah, it will create different. It will create like your mean, your other statistics will be different. Okay, so
Hmm.
that's the reason why you have to adjust by adding plus 1. Okay,
Okay.
clear. So now just let me delete this one. Now, if there is any negative score in your data sheet, okay, if there is any negative score in your data sheet, then what you will do? Suppose this is a negative score. Minus 111. Okay, then we have to make an adjustment. How we are going to do that? Okay, your negative score is minus 111, right?
Hmm.
So what you have to do, analyze, like, transform, compute. Okay, no, 10, then so you have to add, oh sorry, you have to add, it is 11 minus 111, so you have to add plus 112, just one score above the minus score. Okay, clear.
Hmm.
Now click OK. This is your score. Okay, this is adjustment. Clear.
Yes.
So in minus, in case of minus, you have to just, I have, you can see this picture. If in this data my negative score was minus 3, so I have added plus 4. Okay,
Okay.
so if your negative if your score is minus 111, you have to add plus 112. Okay, so this is a
Hmm.
way you are going to adjust it. And if you don't use this method, if you know the normal process, then again this will be a blank cell, and that
Huh.
will have impact in your overall calculation. Okay, clear. So this is
Yes.
a logarithmic transformation. Okay. No, in case of positively skewed data. Now, if your data is negatively skewed, remember I'm talking about negatively skewed data. Okay.
Hmm.
Okay. Just let me correct this one. This is the negative skewed. Okay. So in case of positively skewed data, we have discussed how we are going to transform the data. And within the positively skewed data, if any score is zero or if any score is negative, then we have to make adjustment. Now, if your data is negatively skewed, then what you will do? Okay, the say formula is maximum value plus uh, 1 minus variable. Okay, so for that we need to know the maximum value in our data sheet. So we can see here in the, here is the maximum value is 223. So suppose I want to use, this is a negatively skewed data pre-test. Okay, so for that, for firstly we have to know whether the data is negatively or positively skewed. So we have to do the descriptive statistics, frequency, statistics, and notes, units and statistics, computation, and maximum. Okay, so here we can see whether my data is positively or negatively skewed. Okay, so can you tell me which one is positive skewed, which one is negative skewed from this from this table?
Pre-test is negatively skewed and post-test is positively skewed.
Yes. So we can use this logarithmic transformation formula for the post-test data, but in case of pre-test, we have to make adjustment.
Hmm.
Fine. So what we will do, then we go to transform, compute. Okay. Then let me clear some cell.
Hmm.
So in case of pre-test, we cannot use this method. We have to do something else. So I'm clearing this one also. Now transform, compute, test A. So the formula is maximum value plus 1 minus the variable. So here the maximum value is 2. Here maximum value is, in case of pretest, we have to check in the output. Maximum value is 227.
27.
So 227. Okay, I can do it from here. Plus 1 minus variable. Okay, clear? And
Hmm.
then click OK. So this is our score of the transformation. Okay,
Hmm.
so it is clear, the logarithmic transformation. So
Hmm.
generally, if our data is very skewed, we use logarithmic transformation. Okay,
Huh.
now next, this one is clear now, logarithmic transformation.
Yes, yes, it is.
Okay. Now the next method that I'm going to use is square root transformation. Okay, square root transformation. Okay, let me explain the theoretical thing. Then I will come here in the SPSS. Square root transformation means simply you have to square root each score. Okay,
Hmm.
okay. So this is also very useful in case of positively skewed data, and if we use negatively skewed data, then we have to again make adjustment. Okay. So what are the steps of square root transformation? Just a minute. Okay. This yeah. Okay. Go to transform, compute. Okay. Now, uh, we know pretest is a negatively skewed data, so we will use post-test first. Okay, sorry. First we have to, okay. Here in arithmetic, you can find square root option. This is the square root option, SQRT. Please note down. This is the option, square root. Okay. So just send here SQRT, and in this within this bracket, send post test score, and you have to write target variable post test. Yeah, is it clear? Hello, Aparna.
Yes, it is
Okay.
clear. Sorry, the dogs were barking outside, so I kept it on mute.
Okay, I can understand. Okay, we all face this kind of problems. Okay, no problem. Okay, so now this is the transform data. Okay, now if there is any negative, if there is any zero in your data, what you have to do is the same process we use in the logarithmic transformation. Go
Hmm.
to square root, send it here in under numerical expression, send your data here, post test score, then add +1.
Plus one.
Same process, and click OK. Okay. This is your data. Clear?
Yes.
Okay. Now, if there is any uh, just a minute. If there is any negative score, same way we have to do. Suppose this is a negative score, -9, then transform, compute, negative, square root, then post test. What we have to do, our score, negative score is -9. So here we have to add
Plus
plus, we
10.
have to 10 once. So again, you can see same. Okay, we have data here. Okay,
Hmm.
clear? Okay.
Yes.
Now, what we will do in case of pretest, this is a negatively skewed data. So we'll go to transform, compute, test, 9, arithmetic, output. Okay. Then we have to add we have to add maximum score. Here our maximum score is 223.
Hmm.
223. Uh, there is option. Now, plus 1 minus the variable. Okay.
Pretest. Hmm.
Okay. So this is the transform data for the negatively skewed. distribution. Okay. Now we can use them for our analysis. Clear?
Yes.
Okay. So logarithmic distribution and square root transformation and logarithmic transformation, both of them are clear.
Yes, they are.
Okay. Now there is another method which we can use, that is reciprocal transformation. Okay. Reciprocal transformation means you have to divide one by each score. Okay. So if like in your data sheet, in your data, like you have to divide one by 123, by 77, 119, and in this way. Okay. So obviously we are not going to do it manually. We have SPSS, so SPSS will do this. Okay. So just let me clear this column, then I'm showing you how we are going to do that. So let's go to transform, compute variable, at the reciprocal transformation. Okay. So here also we have the option arithmetic square root. Oh no no no. Okay, sorry. We don't have the option here. We just
Okay.
simply have to write one by the variable. So in case of post test, we'll do it directly because it is positively skewed. Okay, you
Hmm.
have to write under numeric expression one by post test. Okay.
Hmm. Hmm.
Okay.
Huh.
The reciprocal transformation, and if it is negatively skewed, in case of pre-test, we have to do the if there is any zero or one in the zero or negative score in the data. Okay, I forgot to change this positive as a positive, so this is a error. This is an error.
Okay.
Okay. Anyway, you understand the concept now.
Huh. Huh. Huh.
So if there is any zero or negative score in your data, then you have to do the same process. Okay, with one you have to add plus one, or you have to make the adjustment the same way. Okay. Now,
Uh,
if it is a negative score, negatively scored data, then we have to go to the compute variable. It's one. Sorry. Sorry, maximum score. Mm, 93 plus one. Uh, just a minute. 1 by
mm.
223
Plus one.
plus 1 minus the variable. Okay. You have
Just
to
a.
make adjustment with the
Yeah.
then click OK. This is the score, adjusted score. Yeah.
Yes.
In the same way, if there is a negative score or there is any zero, you have to make adjustment not with the variable. Like you have to write If there is 0, then it will be post test plus 1, like this. Clear?
Huh.
Okay, and if it is negative, then post test plus the one next number. Like if it is negative 3, then post test plus 4,
Oh.
like this. Okay, so basically the process is same. Now, once you have transform score, when we will do the data analysis, we will use this transform score, not the raw score. Okay, clear? Okay, any
Yes.
question?
No, not as of now.
Okay. Now, we'll check for the assumptions. Okay. So, what do you mean by assumption in any statistical analysis? What are the assumptions? Any
Um,
idea you have?
uh, like I know that like when we have used it in class, it's sort of like if they have if it's like a theory being discussed, we talk about like sort of like the ideal situations. So it's sort of like if something is in a certain way, there will be two, three factors mm, which are in a certain way. So it's I'm not being able to, I'm not like explaining properly, but then that's what my understanding is.
Okay. Assumptions means basically when we are doing any statistic, assumptions can be anything. Okay, like when you are doing a research, you have certain assumptions that we say hypothesis, and we develop hypothesis from the assumption. But when we are doing any statistical analysis, we have to check whether our data has fulfilled certain assumptions. Okay, so if I want to use parametric statistics means like T or ANOVA. Okay, uh,
Mm.
okay, so or whether we are going to use non-parametric. Non-parametric means like man with you or Kruskal-Wallis or many other things are there. Okay, so the first thing we see, okay, if the data is large, we are going to use parametric. If it is small, then we are going to use non-parametric. Okay, but that is not the only assumption. Many times it can happen that even if our data is a large one, still, the data does not fulfill the assumptions of normality and homogeneity. Okay, these
Mm.
are two very important assumptions of parametric test. First, your data, it is assumed that the sample of the score drawn from a normally distributed population. Okay, so
Huh.
now last day we draw a lot of graphs and we discuss about how normal graph should be, how the graph should be, or what is expected, or if it is skewed, then what we are going to do. Okay, so why we are doing this thing? Because of the normality assumption. So it is expected that our data actually is a normally distributed data. Okay, if our data is not normally distributed, then we cannot use parametric statistics. Even if it is a large, it is a like the n is very large. Even if it is 1,000 data, still you cannot use parametric statistics if it is not normally distributed.
Oh.
Okay. And second
Mm.
assumption is homogeneity of variances. Means your variances are homogeneous. Means variances means we know the distribution of score, spread of score. Okay, so suppose like the how the scores they are spreading across mean. Okay, it's not like that every score is homogeneous same. They are similar. So how they are spreading across mean. So if your data in your sample they have homogeneity of variance means the spread is equal, then only we can use parametric. But if the spread is not equal, if the SD like SD vary a lot, like this happened in case of outlier. Okay, we cannot use that parametric test. Then we have to go for the non-parametric test. And many times, even after correcting the outlier, even after transforming the score or changing the score, still the data does not fulfill the assumptions of homogeneity. Okay, so whether I'm going to use parametric test or whether I'm going to use non-parametric test, that I will decide by checking these two assumptions. If my data fulfills these two assumptions, then only I can use parametric test. Okay, is it clear?
Yes.
Many times we have a believe that okay, I have so many data, like it's a thousand, my n is 1,000 or 10,000, so I can easily use parametric. I don't have to use non-parametric. But that is not right. You have to check your these two assumption. If they are satisfied, then only you can use parametric. Like in my PhD thesis, when I used, like there was 1,000 sample of 1,000. The data was like I have collected data from 1,022 individuals. Okay, and when I checked the assumptions, I saw that the data did not fulfill these two assumptions. So even if I have collected data from 1,000 individuals, I have to use non-parametric statistics.
Parameter.
Okay,
Okay.
so uh, how we can test assumption of normality? So first, tell me, is it clear what we mean by normality?
If the data can be presented in a normal curve.
Yes, yes. Normal curve. It is not much skewed. Yeah,
Hmm.
so more or less normal. Then, like we can say that our sample is drawn from a normally distributed population. Okay. So
Hmm.
there are two tests we can use to test the assumption of normality. The first test is called Kolmogorov-Smirnov test. We use this test generally if the sample is more than or equal to 50. Okay.
Okay.
And the second test is Shapiro-Wilk test. We use this if the sample size is less than 50. Okay. Now, what this test they do, they compare the score of the sample to a normally distributed population, and that population has same mean and standard deviation like our sample. Okay, so and they see whether the sample they have significant difference or not. So suppose my sample is, just hypothetically think, my sample is B and the normal distributed sample is A. Now
Hmm.
both A and B, this sample, they have same mean, same ST. Okay. Now if we test whether there is significant difference between A and B, and if there is significant difference, then we can say that B is not normally distributed. But if there is no significant difference between sample A and sample B, then we can say that okay, B is normally distributed like A. Is it clear?
Just a second. I just want to read it.
Okay.
Yeah.
Okay, so
Hmm.
in case of both Kolmogorov-Smirnov test and Sapir-Whorf test, if the test result is not significant, then only we can say that our assumption is fulfilled. It is a normally distributed population, and we are going to use parametric test. Okay,
Hmm.
okay. Now, how we are going to use test this thing using SPSS? So these are the steps. Okay, so let me check it. Okay, I will do this normality test for both raw data and the transform data. Okay, and then let's see if there is any difference. For the pre-test, let's go to analyze, then descriptive statistics, then go to explore. Okay, here independent lists and pre-test and post-test. Okay, and go to plots. Here normality plots with test. Fine,
Hmm.
clear. Then continue. Okay, so this is the, so whenever you are using this steps, you will get both Kolmogorov and Sapir-Whorf. But if you're whether you are going to use this one or this one depend on your sample size. Okay,
Okay.
yeah. So I have used this I have given the steps and the pictures, so if you can remember later. Okay. So if your sample is more than 50 or equal to 50, we are going to check Kolmogorov. So
Hmm.
here our sample is 50. So we are going to consider this one. Okay. So we can see that this is not significant and this one is significant. It means 0.0 is 0.01, right?
Hmm.
Okay. So we can say that this is not normally distributed pretest code, and post-test code is normally distributed. Okay. Clear? Now, whether in case of pretest and post-test, this is a very difficult situation. I faced this thing a lot when I was analyzing my PhD thesis. That in pretest it is not normally distributed, in post-test it is normally distributed. Okay, but in this situation I use non-parametric statistics, not parametric. Even if it is this one is fulfilling the assumption, still I use non-parametric. Okay.
Yeah. So it's like the both should require fulfill the assumptions, then only we can use the parametric.
Parametric, yes, yes. Now it depends on, many times it depends on many things, not only this. Like in this situation, you have to consider your sample size, you have to consider other thing, like you have to check your SD, you have to check your graph. Okay, maybe it is not, it is slightly skewed, not only this test. So in this situation you have to take decision by considering other factors, like you cannot take decision straight cut by only seeing this data.
Okay.
Okay, so this
Okay.
is the situation where the when you have to take your own, no, you can take help from the expert also, like whenever we are doing research, obviously we have guide with us, our uh, guide, or they will help us, like to decide how we are going to do this. But you have to justify, like whenever you are presenting your data, then people will question why you are using parametric or why you are not using non-parametric. Okay, so you
Okay.
have to justify, okay, even if it is not significant, even if it is significant, but when I check the graph, my data is not so much skewed. So I think or my sample size is large, so I think that I can handle that much skewed data, so I use parametric here. Okay,
Okay.
so this is a
Okay.
decision you have to make as an analyst, data
Okay.
analysis. Okay, so generally, if they both of them are significant or both of them are non-significant, we can easily make decision. But this is a moment when you have to think what, why, or how I'm going to do this, and this is a reason why we need different kind of graph. Like we can know skewness and kurtosis from the data also, but still we need graph to justify our analysis during these critical times. Am I
Okay.
clear?
Yes.
Okay, so this is a test of normality. Clear?
Hmm.
So this is significant for pretest. Generally, pretest score, it can be no, not no, it is like it is not normal, because it is a baseline measure, and many times it can be different, people have different score. But once they get a training on something, they may have similar kind of score. It may happen. So generally postage score are not, like you can see here, the postage score is not significant, right? Means it is normally distributed.
Hmm.
Clear? Okay.
Yes.
Now let me use the this test on the transform data. Okay. So if we transform our data, then we are not going to use this one. We are going to use the transform data only. Okay.
Okay.
So let's analyze. Sorry, analyze descriptive and sorry, not explore. Yeah, explore. Then plots. This is a test you can see after
The
both of
transform data. Yeah.
non-significant. They are all non-significant. Okay, so it means they are not normally distributed even after we have corrected the outliers. Still, it is not non-significant. Oh, no, 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 no. Sorry, this is the pre-test. This is the post-test. Okay, so the pre-test is uh, okay. So
Both.
both of them are non-significant. So here we don't have any doubt. We simply use non-parametric test. Both
Hmm.
of them are significant. Okay, so we don't have any confusion. simply we can use non-parametric test. Clear?
Hmm.
Okay. So you don't have to, justify that why I have used this or that. Okay, clear?
Yes.
Okay. Now, next, so this is the normality assumption. Any question?
No.
Okay. Now, next is assumption of homogeneity. Okay. So this is the table you saw. We can see this table here. Okay. Now, testing the assumption is homogeneity. For this, we use this test, Levin's test. Only one test is there, it is Levin test. Okay.
Hmm.
Similarly, if the Levin test is non-significant, then we can say the differences between variance is zero. Okay. And we will use then the parametric one. But if it is significant, then we can say that the assumptions of homogeneity is not violated. So the variances are not equal. Okay, same way, like the Kolmogorov small dot test, same thing. So what we'll do, how we are going to check this. This is the step, same. Uh, Here, analyze, descriptives, statistics, explore. Okay. Here also we will check for the both sets of data. We, we test, thoughts. This one you have to spread level with level test. Here, conducted. Oh, sorry. This one I have to do factor list.
Oh.
Okay.
Hmm.
Sorry. I just click it. Just a minute. Let me do it from the beginning.
Hmm.
Go to analyze this statistics, explore. Okay. Then plot. Okay. Here, if you are using untransformed data, then you have to click here. And if it is a transformed data, then you have to click here. Okay. So this is the untransformed data. So I will click here and then continue. Okay. This is the level test. Okay. So based on mean, if we will check pre-test score, it is not significant, so it is homogeneous. And post-test score, it is 0.05, so it is significant, so it is not homogeneous. Okay. Now, it may happen that your data fulfill the assumption of homogeneity, not normality. In that case, also you have to use non-parametric, and again you have to make decision what you are going to give importance. Okay. It's not like the straight cut. I will say, okay, your data is fulfilling the assumptions of normality, not homogeneity. So you use this non-parametric or you use parametric. It's not like that. In that situation, you have to think, you have to justify, you have to check your SD, you have to check your, the graph, and then you have to decide, okay, what you are going to use. Okay, and you have to check your sample size. Okay, so everything you have to consider, and then you have to use the statistic, and then you have to justify your answer. Okay, am I clear?
Yes.
So it is clear how we are going to use Levin test. Okay.
Yes.
Now, if we use Levin test in case of untransformed data, so Uh, then transform data. Sorry, explore
Plots.
plots. Use transform data. What kind of transformation we have used here? Last one, square root, no?
Hmm.
Now reciprocal. I forgot. This one, reciprocal. Reciprocal.
Reciprocal. Hmm.
So you have to click here. Then continue. Learn test. These are the score. Not significant. Uh, and post test also it is. No, this is the previous score. No. Pre-RT and post-test RT. Okay. Same thing. It is not it is significant 0.05 and
Hmm.
this is not significant. Okay. So you can see that even if we transform our score, it may happen that your score is not significant, and that time you have your score does not fulfill the assumption of homogeneity and normality, and you have to use non-parametric testing.
Hmm.
Okay. It
Hmm.
is clear.
Yes,
Okay.
ma'am.
Now let's do one thing. Let's take another data and we do every steps from the beginning. Okay.
Huh.
Just let me open this one. Come on, fresh.
Data.
Okay. So, mhm. So this is the data. Now suppose we are conducting a research. The research question is the effect of childhood corporal punishment on different psychological variables like subjective well-being, happiness, optimism. Okay.
Hmm.
So just let me write the variables here. The first variable is suppose subjective well-being. B. So I have to write the level here. And second variable may be happiness. Third variable may be optimism. Fourth may be life satisfaction. Fifth maybe what can be anything resilience. Okay. And this is the grouping variable punishment group. Now here I have to define this group values. It is 0 means high punishment and 1 means low. Clear? So what are the steps? So how which steps we have to follow here?
Just a second. Yeah.
First thing, what we have to do? Just remember the last class.
Mm, we'll go to analyze. Descriptive statistics. Okay, wait. Okay, then we'll go to. Do we check the frequencies here?
Yes. Every time start your analysis from frequency.
Okay.
Okay.
Hmm.
So we'll go to frequency. Okay. So here we'll just send all the variables and then statistics. We need mean, median, mode,
Hmm. Standard deviation.
minimum, maximum,
Skewness
skewness.
and
Other things, if you want, you can click also. But if you don't want, okay. These things are most important ones. So here we have frequency for each one, each variable.
Hmm.
Okay, you can see happiness, and we have
I'm
okay,
satisfied. Hmm.
and this is the main table where we can see the mean, ST, and everything. Okay, one more thing, analyze. Okay, create API table,
Hmm.
very important. I forgot to give the punishment. We have to do this because we have to know how many individuals are there under high punishment and low punishment. Okay.
Hmm.
Now I can also compute use this descriptive statistics. Okay. So for that, okay, no, not this one. Then we will draw the graphs. Okay.
Hmm.
So legacy dialog. Then okay, just let me discuss first. For subjective well-being, it is subjective well-being. We will draw bar diagram or histogram.
I still get confused between the two, but I think it's histogram.
Yes, we'll draw histogram for all of them. Okay.
Okay.
So and bar diagram for the punishment group. Okay. So go to graph, legacy dialog, histogram. Okay. Now you have to click it, elements,
Elements.
show distribution
Just
part,
normal.
elements. Okay. So this is electrocardiograph, right?
Hmm.
But okay, let us check the skewness and kurtosis here. Skewness from here. Subjective well-being is positively skewed, but okay. Happiness negatively skewed. Optimism. Okay. So this is a bit positively skewed.
Hmm.
The normal, it will be like this, normal curve, right?
Hmm.
Okay. So
Hmm.
for other variables also, we have to do the same thing. Graph. Then this is
Legacy
the
dialogues.
histogram. And optimism. Okay, we can click here, display normal curve also. Okay.
Hmm.
Oh, I think I have right the subjective well-being again. Happiness. Okay. So this is the curve for the happiness. Here we can see it is positively skewed.
Hmm.
Okay. Then same for the other variable graph. Let us see dialog.
Legacy histogram.
For optimism. This is optimism. Slightly skewed, positively skewed. It is also happiness also positively skewed. And how, so we need both graph and score to understand. Happiness negatively skewed. Sorry, and optimism. You can see optimism is like skewness is very less.
The
No,
less. Huh.
yeah, you can see. We can see here in the graph also. More or less, right? So then this is from last one. No, life satisfaction we have.
Satisfaction.
So it is like this. Life satisfaction is very negatively skewed. Okay, and we have next last one,
Legacy dialogues. Histogram.
resilience.
Resilience.
Okay, so these two are negatively skewed, like minus something. You can see this code, right?
Hmm.
Then punishment group will do bar diagram for them.
Hmm.
Mm, dialog, simple bar for separate variable. Now we'll do cluster bar for this. So this is the high punishment group and low punishment group for both variables. Okay,
Hmm.
fine.
Hmm.
So we need graph to whenever you are like discussing your result or analysis, then graph will give you extra additional justification. Okay, and
Hmm.
always it is better you display your result with graph when you are giving presentation, because people are there like when many data are there, just really not good to it's not really very clear like graph, they give a clear picture, but data, no, many data are there and many tables are there, but they will not give clear picture, especially when you are giving presentation. So it is very always very good you use graph, even if we have score with us. Okay, so
Hmm.
now we will do box plot whisker.
Huh.
Okay. So simple box plot. Somebody specifically boxes represent. So we can see in happiness there is two outliers, 44 and 46. Let us
Hmm.
check.
Life satisfaction.
In life satisfaction, many outliers,
Hmm.
certainly skewed data, and resilience also, like it's
One.
also there is an outlier. And you can see the median is here. Okay, so score is above the median. So these two data, they need lot of transformation and correction before analysis, and these two are good. This one is best one, and this is also fine. This happy as wala
Hmm.
data. Okay, so let us check here in the data sheet. Happiness 46 44. Case number 46 44. So it's 44. Yeah, it's one and 46. You can see this is a outlier, but the scores are less than the other scores, so it is written here in
Hmm.
the below, not in the above. Okay, so this is our box plot. Now we can also use Xcode to check the box plot, especially if in case of life satisfaction and resilience, if we want. So we will go to analyze, descriptive statistics, and descriptive. Then life satisfaction, resilience. Okay, let's take for all of them. Optimism. You can see so many outliers. Oh no, it's not outliers. Yeah, here. 3.39, 3.312, 3 outliers are there in okay.
Hmm.
Under resilience there are also no outlier. Okay, subjective well-being. Okay, clear. So next what we'll do, then we have to do the correction of the outliers if you want to transform the data. But remember, if you want to transform the data, you have to transform all the data, not only one single data sheet distribution. Okay,
Hmm.
clear. Okay,
Yes.
and then we will check the assumption of homogeneity and that assumption of homogeneity and normality. So let us check assumptions. Okay, so we have to go to analyze, then statistic, then explore, and just now plot. We can do them together. You don't have to do them separately. Okay,
Hmm.
11 test. Okay, continue. Both homogeneity and Yes, here we have the Cosmogloss one of test. Here the N is above 50, right? So we'll, if it is here N is, just let me check. Yes, N is above 50. So if it is above 50, we use,
Kolmogorov Smirnov test.
yes, it is above 50, then we'll use Cosmogloss. So here we'll check this one. So you can see that these are all significant. Okay, so they are like we have to use non-parametric here because they are all significant means they are does not fulfill the assumption of normality. Okay, and we check the homogeneity. Okay, homogeneity. Let me check again. So, Colmograph. Homogeneity. Oh, I didn't give transform data, untransformed data, so it's not showing. Okay, we can easily find data from here also. It's spread versus level test. It's the total. Hmm. This is the level test. Okay. So you don't have to scroll down. You can easily check from here. This is the level test. So here we can see these are all. This is a significant level. Uh, this one is not significant. Means this is homogeneous. Happiness is not significant. Homogeneous. Optimism not significant. Homogeneous. Life satisfaction not significant. Homogeneous. They're all homogeneous.
Okay.
Okay, but they are not normally distributed. So here you have to make decision according like following other like other thing like HT and by seeing the graphs and how many skewness is there, everything you have to make decision like what you are going to do. Okay, is it clear?